试想一下，让机器人能够感知到温度和压力，会不会很酷哦？现在我们来听听 Wootzano 的故事。
Every great achievement in science is based on bold fantasies. I wanted to remove the barrier between humans and robots, and the missing link was a sense of human touch. Although it was considered impossible, I have beaten all the odds. Now with an amazing team of scientists and engineers behind me, we are pushing the boundaries of what's possible with our electronic skin within the field of robotics. Our aim is to allow robots to feel and sense like humans do with their own skin. We firmly believe that artificial intelligence and robotics shall bring about more profound changes to human society.
Have you ever imagined having dinner at home made completely by robots? Or robots going into farms and picking up fruits and vegetables? I'm Atif Sayed, founder of Wootzano Limited, and I'm going to show you how all of this is possible right now. One of the issues of robotics and robotic systems in general is robots trying to do manual, dexterous labor. And one of the main things they use are their onboard camera systems. Vision on its own can be obstructed, so you might have noise in front of a robot. Vision does not tell properties of what you're trying to pick, so it does not tell how firm or soft a particular object is. And more importantly, vision only sees the front side, does not give you the full spectrum of information. When you and me try to pick up an object, we'll use our eyes to identify the object, but then we'll let our skin take over the rest, which gives you enough feedback to then manipulate the object in a so-called dexterous manner. So for robots to do exactly the same thing, we need something which is akin to a human skin. And that's exactly what we did. So we have developed a very sensitive or highly sensitive force and pressure sensor integrated with temperature, humidity, and it goes beyond human evolution, and it can smell an object using onboard chemical sensors while it's touching it. And it's completely compliant. So this is one of a standard finger sensors. You can stretch, bend, twist, or crumple the substrate, and the electronics on top of it is unharmed. We not only make skin for robotic hands, we make skin for all sorts of things, foot, and any surface. Because it's so conformable, you can place it on any curved surface possible. So some of the other things we also do is we allow, using a graphical user interface, a real-time view of what robot is feeling. So you can see exactly what's happening on a force feedback and temperature and chemical feedback. And you can save the data to then allow the robot to learn from itself, to pick random objects with ease. Some of the applications for the purpose of the presentations, one of the big ones includes picking up fresh produce, so tomato picking. Tomato being a very soft, fresh produce. Because our sensors are so sensitive, it enables the robot to pick this tomato without bruising or damaging it. So it picks up without also making sure it doesn't fall off. The other big area we are integrating our sensors is the world's first attempt to carry out fully autonomous inspection, maintenance, and repair of offshore wind turbine blade. It's a quick video which explains what this is about. There's an autonomous boat which carries a bunch of scouting drones. So these drones go and scout essentially a wind turbine farm and looks for defect on wind turbine blades. Once a defect is identified, they come back and pick up a spider-like robot, a hexapod. And the hexapod has a foot like this. So this foot here, again, is compliant and has a skin integrated within it. It allows the robot to balance itself and walk in a surface and environment which is completely unpredictable and quite extreme. So again, this is one of the other areas how we're making robots more integratable. The other future applications, which are not too distant in the future, one of it is allowing amputees using a prosthetic limbs to really have a sense of touch and feel. So right now, there's no way for us to be able to do that. So we're working with leading prosthetic limb manufacturers to do that. And we're also integrating this into dental surgical robots. So the impacts here are quite a few. The three big ones are by allowing robots to pick fresh produce at the same efficiency or better efficiency than humans, you are actually making sure food is not wasted. More importantly, you're removing humans to go into dangerous and extreme environments. So this is one of the robotic foot. The inside of it looks pretty much like this. And this one is pretty much bulletproof and radiation proof. So it allows robots to go and decommission nuclear power plants. You don't want humans to go in there and get radiated to nuclear radiation. And more importantly, we're breaking the barrier between humans and robots by adding a sense of touch. We are a small team, but we're rapidly growing. In the next few months, we have another 9 or 10 hires to do. And at the moment, we're making about 120 sensors a day. For a company of our size, I think that's a great achievement. And also consider that this is a completely new substrate and material. No one has done this before. With this, I'd like to end by saying, let's all come together and believe that artificial intelligence and robotics can bring about profound changes to human society. Thank you very much. Shishi Dajia.
我们把掌声送给阿 T。Thank you.
No worries.
All right, let's come to the center stage. 我们要开始我们的问答环节。我们的问答环节开始，我们的打分通道也开了。这一位置，所有的观众朋友们，你们要拿一下你们的这个打分器，开始打分数。哦，好的。那我们先问一下评委有没有问题。So let's ask our judges. Do you have any questions for Atif?
Sure. You've listed several example applications, but can I sort of understand or get a better understanding of exactly what your company's doing? You're not building the robots, right? You're building the sensors. So in that case, are you working directly with robot manufacturers, or so? Can you explain a bit about that?
So, like you said correctly, we make skin, we make the machine learning algorithms, the electronics behind it. And we work directly with robotic manufacturers to integrate our skin into the robotic end effectors. So we work with people who make end effectors, so dexterous hands. You make people who are making grippers. So essentially, we retrofit it to existing robotic systems to then be placed into our customers' premises. Some of our bigger customers already have robots, and what we do is to directly work with those customers to retrofit our sensors in. A lot of our new customers, primarily the distributors of fruit and veg, who have no idea about robotics, we go and essentially provide them using our partner companies. One of them is actually based in Shenzhen. I was here 4 months ago trying to get a few things in. And we use those robots and essentially give them a full solution. But we don't make robots because that's been already done, and many people doing a better job than us.
All right, awesome. Do we have any more questions?
How do you evaluate the trustworthiness of, are you using this technology for critical systems, safety critical systems? How do you evaluate the trustworthiness of the AI technology you are using?
I didn't hear that right. Did you say electrical systems?
No. How do you evaluate the trustworthiness of the AI technology you are using?
At the moment, so when I say AI, of course, it's not completely randomness. So we're using supervised machine learning. So we have a seed data, which is collected from humans, and we use that as a base level. So the humans are pretty much the best way how to pick objects. And what we're trying to do with the robotic systems is to do that every time in the same possible manner. And the machine learning part is really, we don't want robots to do a random thing every other day. So we want them to do the exact same thing every time. But the difference is, every time there's a different type of tomato, a different shape of tomato, the robot should be able to look at it and identify and manipulate it based on the seed data we provided.
Awesome. Fantastic. Do we have any more questions?
Sure. I would like to know what your competitive advantage is. What unique thing do you have that no competitor has?
So one of the biggest one is the material, which you've seen. So we use a completely new material, a polymer, which allows us to fabricate using standard microprocessing and nanoelectronic processing materials, and we are able to fabricate electronics directly on top of it. So when you stretch and bend and twist, you're able to then see feedback, which you won't be able to see generally, and also to be able to massively scale up the sensors. And that's one of the main things we have developed, which at the moment no one else is able to do.